Okay guys, today we are starting our next chapter in Unit 4. We're talking about translations, and this is Chapter 6, Lesson 1. First of all, we need to know what a transformation is. Well, a transformation is whenever we change an image, whenever we have something and we change it somehow. So a transformation is where we have an original image. That's called our pre-image. That's the original. And then we move it, we spin it, we do something to it, and we get a new figure, and that new figure is called the image. Specifically, a translation slides a figure from one position to the other without turning it. It's not going to turn the shape, it's just going to move it from one position to another position without changing which direction it faces. So a translation, if I wanted to define that in my own words, I could put it slides a figure without turning it. It's going to face the same direction that it faced originally. It's just going to be slid from one position to another. List 3 characteristics. Well, the 3 characteristics, let me think about this first. One characteristic is that it stays the same, so the size is the same. It doesn't make it larger or smaller, it just moves it. Also, the shape is the same. I'm not going to write that out again. I'm just going to write this because that means the same word. Shape stays the same. And finally, it doesn't turn. It always faces the same way. So, draw an example of a translation. So here is my triangle. I can translate it to the right. It's still going to be the same shape and the same size. I can translate it up. It's still going to be the same shape and the same size. And that one's a little bit smaller, but that's because I'm freehanding it. But you get the idea. It does not change the direction that it's facing, and it doesn't get bigger or smaller. So if I did a non-example, well, if the points over here, a non-example would be if I were to flip it. If I were to flip this triangle at all, that would be a non-example because I've changed which direction it faces. Okay? So let's look down here. This is talking about a computer program, and someone has designed something on a computer, so it's a little bit hard to see. But here is A1, or here is A, and here is A1. Now this is my pre-image. A is my pre-image, and I know that because it doesn't have a special character above it. A1 then is my new image. So this is where I started originally, and then this is where I went to. And it says what motion was used. Well, you can see that it went here first, and then it went down. So it moved right, and then down. In fact, it translated right and then down because it didn't change which direction it was facing. Okay? It says compare the size, shape, and orientation of the design piece in its original position to that of the piece of the news position. Well, has the size changed? No. Has the shape changed? No, it's the exact same shape. And has the orientation, which way it is facing, has the way it's facing changed? Well, no, this arrow right here is still facing down, this arrow right here is still facing down. So the answer is it remains the same. None of those things changed. It just moved from one place to another. Okay? So let's look over here. Now we're talking about congruence. And congruence just means the same shape and the same size. So if I translate an image, let's say I translate a letter L. If I translate that letter L over here, here is my original image. It doesn't always have to be an A. In this case, I'm just using an A. Here's my new image. Have I changed anything about that letter L? Well, if I translated correctly, which granted this one's a little bit fatter than this one, but if I would have translated correctly, then no, this one should be the exact same size and the exact same shape as this one, so they should be congruent. Let's look down here. We're going to go on down to A and do one together. It says graph triangle ABC with vertices. Well, my first vertices, my first point is at 4, -3. So I'm going to make a point at 4, -3. That's my A. Okay? B is at 0, 2. So here's 0, 2. So here's my B. And again, this is a triangle, so I'm going to go ahead and connect these two. And C is at 5, 1. So I'm going to count over 1, 2, 3, 4, 5, 1. So here is my C. Okay? So here is my triangle. And it says then graph its image, which means I'm going to graph another one that moves 4 units left and 3 units up. So each of these points are going to be 4 units left. So 1, 2, 3, 4 units left and 3 units up. 1, 2, 3. So my new A now is right here at 0, 0. Because I've taken this original point and I moved it 4 to the right. Or I'm sorry, 4 to the left and 3 up. So my new point is now at 0, 0 for A. B, if I move it 4 to the left, there's 1, 2, 3, 4 to the left, and 2 up, 3 up, sorry. 1, 2, 3. Here's my new B. So my new B is at 4, 5, -4, 5, sorry. -4, 5. And my new C, if I go 4 to the left and 3 up, here's my new C. And I'm actually going to do that in a different color so that you can see my new triangle. Here's my new triangle. Here's my new B, so I'm going to make that B1. Here's my new C, so I make that a C1. Here's my new A, so I make that an A1. My new C now is at 1, 4. Does everyone see how I did that? I just took this triangle and I moved it 4 to the left, 3 up. It's the same size, it's the same shape, so it's congruent to this triangle, but I moved it to a new position on the coordinate plane. Okay? Let's do this one over here. This one wants us to do it mathematically. It doesn't want us to graph it. If I move to the left, if I go to the left, then I subtract from x. Okay, so if I move my image to the left, then I'm going to subtract however many spaces that I move from my x. If I move to the right, then I'm going to add to x. Okay, so if I move to the left, I'm going to subtract from x. If I move to the right, I'm going to add to x. If I move up, I'm going to add to y. And if I move down, I'm going to subtract from y. Okay, so left, I subtract from x. Right, I add to x. Up, I add to y. Down, I subtract from y. So let's look at this one. I have 4 coordinates. I have A, B, C, and D. Okay? My original A is at 0, 0. My original B is at 2, 0. My original C is at 3, 4. And my original D is at 0, 4. So those are my original coordinates. That's what it tells me. A is at 0, 0. B is at 2, 0. C is at 3, 4, and D is at 0, 4. And it says that I'm going to move 4 units right, so that affects my x. So 4 units right is going to affect my x number because I'm going right, I'm adding to x. So I need to decide, what are my x's in this? Well, I know that whatever my x is, I'm going to add 4 to it because I'm going to the right. If I go to the right, it adds. So whatever my x is, I'm going to add 4. And then if I look at my y, I'm going down 2 units. If I go down, then I subtract from y. So from whatever my y is, I'm going to subtract 2 because that's how many units I'm going down. So on this first one, my new a then, I'm going to add 4 to my x, and I'm going to subtract 2 from my y. This first number is my x, so I'm going to add 4 to that. So my new image at A1, 0 plus 4 is 4. 0 minus 2, because this is my y, and from my y I subtract 2, and 0 minus 2 is a negative 2. So same thing for my B1, whatever my x is a 2. I'm going to add 4 to that to get 6. Whatever my y is, which is 0, I'm going to subtract 2 from to get a negative 2. My c, my new c, I'm going to add 4 to my x, subtract 2 from my y. And finally, my new d, I'm going to add 4 to my x and subtract 2 from my y. So these are my 4 new coordinates. Okay? Last example, we're going to actually use this on our last example. It has this animal, this drawing, and it's been translated here. And it wants to know, what is the new location of A? Okay? Well, A is right here. It's the same place as B. And if A was located at +3, -2, we know that this one, point A is at 3, 2. Nope, I'm sorry. 3, -3. I don't like how they have that written. Oh, see, I read this and I saw these as negatives. But in my mind, I knew that if I go up, that can't be negatives. But if you look at that, it looks like it has negatives here. Those are not negatives. Those are if I were to continue drawing the coordinate plane. I'm not sure why they did that. That's a terrible representation. But that's just showing where the coordinate plane continues. This is not a -4. And I know that because when I go up on the y-axis, those are positive numbers. So A is at +3, even though it looks like a -3. That's a +3. B then is at 2, +1. And it says, what did it translate? Well, from 3 to 2, what did I have to do to get from 3 to 2? Well, I had to subtract, which means I had to go up or down on my x, or left or right on my x. Well, hopefully you know that it meant that you have to go left because you're subtracting 1. So because I subtracted, that meant I went left. How many units? Well, how many units do I have to subtract from 3 to get to 2? Hopefully you know that 3 minus 1 is 2, so I went to the left 1 unit. From 3 to 1, remember you subtract when you go down. So I am going down because that's when I subtract from my y's, and my y got smaller. So I went down. 3 minus how many equals 1? And the answer is 2. Okay? So now if I were to write that, I would write, what did I do to my x? And what do I have to do to my y? Well, because I went left 1 unit, if I look up here to go left, do you add or subtract to x? Well, you subtract. And I went left 1 unit, so I subtract 1 from my x. Okay? Oops, not x. I subtract 1 from my x. And what do I do to my y? Well, I went down 2 units to get my new coordinate. So down 2 units. So when I look at y, do I add or subtract when I go down? Hopefully you can see you subtract when you go down. And how much do I subtract? Well, I subtract however many units I went down, and the answer is 2. So to get my new y's, I'm going to have to do y minus 2. Oops. Okay? All right, guys, try some of these out on your own and bring all your questions back to us tomorrow. Have a great night. Bye.